No. Prempeh for a bonus. Isaac.
The addition of sulfur to the rubber provides a cross link between the molecules so that the molecules join together to form.
What kind of cross link?
Intermolecular cross link between the molecules because of the sulfur.
Okay, for a bonus, he didn't quite say so, but because he talked about intermolecular, it's the sulfur bridges. Those are the because I wanted you to realize that it's not between the carbon and the hydrogen. It's the sulfur, but it's okay, I'll give you a bonus. Prempeh College, when we are feeling cold, we shiver. Why do you think this is beneficial? Kofi?
Because when you shiver, the rate of metabolism in the body will increase. And when that happens, more internal heat energy will be produced.
No, yeah.
Because when we shiver, we use most of the we use our body, the metabolic activities of the body increases and generating heat in other things.
That sounds different from what Kofi said. Opoku Ware for a bonus.
Let me try.
Nicholas.
When you shiver, you produce heat energy, and this heat energy produced evaporates the sweat, and therefore you feel better.
You know, when you are shivering, it's the muscles are rubbing against each other. So it's the muscular movement which gives you the energy. I mean, the extra heat. All right. So you should have mentioned the muscles and them generating the heat. Opoku Ware, at very high altitude, have a higher red blood cell count. Why do you think this is beneficial? Mike?
This is because the amount of oxygen at high altitude is very small or low. So more hemoglobin has to be produced in the body so that more oxygen can be transported in the body.
Prempeh College, the mean of three numbers x, 2x, 3x is 10. What is x? Isaac? 5. Opoku Ware, the mean of three numbers 3, 5, x is 4. What is x? Kubiti? 4. Prempeh College, according to Newton's first law, everybody continues in its state, everybody, that is a body, continues in its state of rest or uniform motion in a straight line unless acted on by some external force. Experience, however, shows many familiar examples of motion in which moving objects come to rest when apparently left on their own. Does this not contradict the Newton's first law of motion? And explain. Yes, Kofi?
No, because friction is acting on the body.
Yeah, if you are examining it. Opoku Ware, experience shows that it is more difficult to push an object at rest, that is a broken down vehicle, to get it moving than when it is already in motion. Why is this so? Is your hand up, Nicholas? No. Yes, Nicholas.
Because sliding friction is always greater than dynamic friction. Therefore, you...
Prempeh for a bonus. Kofi?
Because first of all, work will have to be done to overcome the frictional force acting on the body at rest. But when the body is moving, the body has already overcome most of the frictional force.
No. This is due to what we refer to as inertia of the body. Okay? Inertia is rather the body's reluctance to change. So when it's already sitting, it doesn't want to change. Okay? But when it's already in motion, easier. Right. Prempeh, in one of the methods for gold extraction, the crushed ore is mixed with cement and made into pellets, which are then heaped on a pad. The heap is continuously sprayed with cyanide solution for about 30 days. Isaac?
Because the cyanide dissolves the gold.
Well, that's good enough. The cyanide will react to give you a compound that is soluble in water. So I guess that's good enough. Opoku Ware, bioleaching technology has been introduced into gold mining in Ghana. What is this technology?
Biotechnology.
Prempeh for a bonus. Kofi.
You will add a solvent to the soil so that the gold will be dissolved and it will leach through the soil and will be collected.
What are you going to say about the bio part? No, it is not correct. Well, this is a relatively new technology in the country, and so it's okay that the students are not. But this is bioleaching is a process where you actually add a certain type of bacteria added to the gold, and these bacteria, they actually eat the gold. I mean, they eat the sulfur, and once you break up the sulfur, you release the gold, because the gold is there just mixed with impurities, and you can then leach it out. So the bacteria are breaking up the gold ores by eating up the sulfur, so that's why we call it bioleaching. Prempeh, house lighting circuits, that is when you put lights in the houses. House lighting circuits are so designed that each electrical appliance is connected in parallel with the others. Why? Yes, Kofi.
It is done so that they will all have the same current flowing through it.
The potential difference is the same because these are in parallel. Okay, it's that concept. Opoku Ware, you know what the Christmas lights are? Those small lights that come out around Christmas. We will call them Christmas lights. Are the bulbs of Christmas lights connected in series or in parallel? And why? Are they in series or in parallel? And why? Mike.
They are arranged in parallel so that different current passes through them at different times.
Okay, go on, Nicola.
They are arranged in parallel so that different quantities of current can flow through them to produce different colors.
No. Prempeh for a bonus. Kofi.
They are arranged in series because if a bulb is missing or is not working, all the lights will not come on.
No. They are connected in parallel so that when one of the bulbs is out, the others will still be on. Because if in parallel, then the potential difference across them is the same. Now, Prempeh College, how is desmodium dispersed, and what feature of desmodium makes this mode of dispersal possible? Yao.
It is dispersed by animals, and it has hooks on it that attaches itself to the skin of the body.
Opoku Ware, how is combretum dispersed, and what feature of combretum makes this mode of dispersal possible? Mike.
Combretum is dispersed by wind because it has light weight and wind-like features.
Okay, wing fruit. I'll give you. Now this preamble is to both schools. Make a valid deduction from the following statement. Make a valid deduction from the following statement. Prempeh College. S1, that's the first statement. All brilliant students use brilliant soap. The second statement, Kofi does not use brilliant soap. I want a valid deduction from the two statements. Just one attempt now. Yes, Kofi.
Kofi is not brilliant.
Kofi is not brilliant. Opoku Ware. Again, make a valid deduction from the following statements. First one, a student who gets malaria goes to the hospital. The second statement, yesterday, Mensa, a student, went to the hospital. Only one attempt.
No, that doesn't mean
Nicholas.
That doesn't mean the student got malaria. That doesn't mean Kofi got malaria.
Prempeh for a bonus. Kofi.
Mensa has malaria.
Mensa may be having malaria. Okay? Mensa may be having malaria. Now, viewers, that brings us to the end of the second round. Prempeh College has increased the lead and leading by a comfortable margin at the end of the second round. Here are the scores. Opoku Ware, 25 points. Prempeh College, 42 points. Our problem of the day today is worth 6 points. This is round 3, where both schools are working the same problem. So both schools can gain 6 points at the end of this problem. At the end of this round. We have a problem which takes more time, so we give the contestants 3 minutes within which to give us a solution to the problem. At the end of the period, they put on the board their solution. We give our own solution, make a comparison, and then award marks on the basis of what they have written on the board. As I said, the problem of the day today is worth 6 points. And here we are. The contestants can turn their seats over now. During photosynthesis, the energy absorbed from the sun is approximately equivalent to plus 2,840 kilojoules per mole of glucose synthesized. The contestants are to calculate the enthalpy of formation of glucose, given that enthalpies of formation of water and CO2 are minus 290 kilojoules per mole and minus 390 kilojoules per mole, respectively, for water and CO2. Viewers, this is the problem of the day. The contestants are still calculating enthalpies of formation. We will take a break and a message from our sponsors. We'll be right back, so please don't go away. Welcome back, viewers, to round 3, the solution to the problem of the day. We have solutions from the 2 schools, so I'll call a contestant each from the 2 schools to go to the board and show us how they solve the problem of the day.
we have on the paper today.
Viewers, we have the solutions from the two schools. Opoku Ware is on my right and Prempeh College on my left. The problem was such that the energy absorbed in the synthesis of glucose was given, and then the enthalpies of formation of two other materials were given, CO2 and water. And the contestants were to calculate the enthalpy of formation of glucose from that information. How we wanted to go about it was to recognize that the energy absorbed that is given is really equal to the enthalpy of formation of glucose minus the enthalpy of formation of the constituent materials, which is CO2 and water. Now, first of all, you put down the equation, which both schools did. You put down the equation to see that 6 moles of CO2 plus 6 moles of water will give you 1 mole of glucose plus oxygen. But because the oxygen is an element, it really doesn't have enthalpy of formation. You sort of equate that one to 0. So you more or less don't deal with it, in the sense that the energy of 2H4O kilojoules is equal to the enthalpy of formation of glucose, which is what we want to find, minus the enthalpy of formation of the constituent compounds that form the glucose, that is of CO2 and water. So if we equate that, then it's 2H4O kilojoules is equal to delta HF, that's the enthalpy of formation for the glucose, which we don't know, minus 6 times the enthalpy of formation of CO2, which is minus 290, and that of water, which is 390. So we get 2H4O kilojoules equals to delta HF of glucose that we want to find, minus 6 times into brackets minus 290 minus 390. So if you do it that way, the terms in the bracket will work out to be minus 680 times 6, because there are 6 moles each, which is plus 4, is 4040. It's minus 4040, but we want the 2H4O kilojoules, which is the energy that you given, is equal to what you want to find, that is the enthalpy of formation of glucose plus 4040, because it's minus minus. Okay. And if you work it that way, delta HF4 glucose will be minus 1,200 kilojoules per mole. Okay. So this is how we wanted it worked out. You write the equation, you set the energy against the enthalpies of formation of what you want minus the constituent compound. So with that background, let's look at the solution for Opoku Ware. They put the statement, they put the equation down all right for the synthesis of glucose, but the reaction is the enthalpies, there are 2 enthalpies there, and then you see they have the 2 enthalpies and then the minus 2480, but what is missing is what they had to find. You have to find the enthalpy of formation of the glucose. Okay. And so after the putting down the equation, everything else started going downhill. It's the same type of solution that Prempeh College also did. Okay. So I think from that point of view, both schools missed the point, but since they put the equation down, at least certain aspects they knew what they were talking about. But I really can't pass them, so I give both schools 2 out of 6. Here are the rules for round 4, where most of the questions involve calculations, and the contestants will have 30 seconds within which to give an answer. If the question does not involve calculations, then they will have 15 seconds within which to give an answer. Correct answer again is worth 3 points unless it's a bonus, in which case the correct answer is just 1 point. Good luck to both of you. I'll go back, start with Opoku Ware. Opoku Ware, find the equation of the line which passes through the point 2 and minus 1 and is perpendicular to the line 2x minus y equals 2. Kubiti.
Y equals minus 1 over 2x plus 3 over 2.
Okay, go on, Nicholas.
2y plus x is equal to 0.
But yes, Nicholas, that's correct. Prempeh College, find the equation of the line which passes through the point 2, 2 and is perpendicular to the line y equals x plus 1. Isaac.
Y plus x minus 4 is equal to 0.
Yeah. Opoku Ware, where in the body, this preamble is the same. Where in the body would you find the following? And I'm going to alternate. Only one attempt. I don't pass these types of questions on over. Where in the body would you find the following? Opoku Ware, laxial. Mike.
The villi.
Yes, the villi. Prempeh College, Harvestian Canal. Ayao.
It's in the bones.
It's in the bones. Opoku Ware, pyramid. Mike.
The kidney.
The kidney. Prempeh College, cement. Yao.
In the teeth.
In the teeth. Opoku Ware, neural sign. Mike.
In the vertebral bone.
The vertebral column. The last one to Prempeh College, pituitary gland. Kofi.
At the base of the forebrain.
The base of the brain. Opoku Ware, a lump of clay of mass 0.2 kilograms and moving at 20 meters per second strikes a wall and gets stuck to it. What impulse is exerted by the clay? Nicholas.
4 Newton seconds.
Well, it's all right. The physicist on the team says that if you omit the negative sign, it's all right, I should give it to you. So I'll give it to you. But it's minus 4 kilogram meters per second. Prempeh College, a ball of mass 0.2 kilograms moving at 5 meters per second collides head-on with a 0.3 kilogram ball moving at 2 meters per second in the opposite direction. Find their final speed if the balls hit together. Isaac.
1.5 meters per second.
No. Yao.
3.2.
No. Put your hand up, Kofi. Yes.
3.2.
Opoku Ware. Kubiti.
6.8 meters per second.
No. Then it's 0.8 meters per second. Opoku Ware, two similar spheres made of the same material have weighed 32 kilograms and 108 kilograms respectively. If the radius of the smaller sphere is 6 centimeters Find the radius of the larger sphere. Nicholas.
It's 20.25 centimeters.
No. Come to college for a bonus.